Okay. Just trying to get a lay of the land here.
Uh-huh.
All right. We got plenty of stuff here. Right. So we've been talking about this already, right?
Yeah.
Let's see here. Trying to send your work. Okay. Not quite correct.
Yeah.
So here's the deal. Kind of do it piecemeal. I'll give you a good example. You ever see people like cutting trees or like chopping
Yeah.
a tree down? They kind of do it piece by piece, right? Like if you have a big oak tree,
Yeah.
you don't just cut it at the trunk. That's what's going to
Yeah.
happen. It's going to come and collapse the house, or so you have to kind of like you see those guys go up in those like little elevated, um, whatever they call those lifts, and they kind of
Yeah.
like the top of the limbs, and
Uh-huh.
someone catches it, and then they kind of cut from the top, and then when they finally feel like they could move the bottom, they will, right? So that's kind of what you
Yeah.
have to do here. Just kind of want to do it piecemeal. So it's kind of like a separate problem here. You have this, right? Now, what does that really mean? This means you want it three times.
Yeah.
You want 2xy squared three times. So 2xy squared times 2xy squared times 2xy squared. What's 2 times 2 times 2?
2 times 2 is 4 times 2 is 8.
Okay, right. Then x cubed,
Yeah.
and then y6.
Uh-huh.
There you go.
So
That's that part. And then you bring on the other piece. Into the mix.
uh-huh.
So now you make it a little more streamlined, right? Oh, if 8 times 2 is 16, x3, x2 is x5, y6, y3 is y9, and z. And that would be your final answer for that one.
Uh-huh.
So that's what you have to show. Now, along the same lines, let me do a screenshot of that. Oh, actually, for a PDF. Here we go. Okay. Along the same lines,
Yeah.
number two, you have the 4 on the outside. So you got to do this. So you want 3 and 5 are 3, 4p4,
Yeah.
4 times.
Uh-huh.
Okay. So, we're going to write like this.
Yeah.
Now, I don't recommend this because it takes a while.
Yeah.
There's a shortcut, but I want to do this first with you so you can see what's under the hood. Like, for example, I got my for my car, I got my oil change and some other things done last week.
Yeah.
I drove in. They said lift the hood, start the car, blah blah blah. And I know they're opening a cap and pouring stuff in, but if I had to do it myself, I wouldn't feel too comfortable because I didn't really see what they're doing, right? Like, I didn't really understand. Like, okay, like maybe the car's really hot. Maybe you got to wait a few minutes. Maybe you got to use a little glove. Maybe there's a little tool. Maybe underneath you have to have a drip pan. Like, so I didn't see everything, right? So it's
Uh-huh.
hard for me to do on my own. And so if they just kind of just told me, well, here's a shortcut, you can, but like I need to really understand what's happening. So I don't want you to show you the shortcut. I want you to understand what's happening. This is what's happening, right? Like I'm trying to give all these analogies to kind of help you, make sense of it, right? So
Yeah.
you want this 4 times. Well, 3 multiplied 4 times, if you use a calculator, is 81.
Yeah.
4 multiplied 4 times is 256.
Uh-huh.
Now you have P4, 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 P4. How many P's is that altogether?
3. Oh no. P4, 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 P12,
One more.
P16.
Right. Mm-hmm.
Uh,
How about M5? M5, 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 M5.
M20.
Right.
Yeah.
R3, 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 R3.
R3, 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 R9, R9, yeah.
R,
9.
no. Yeah, 4 of them.
R12.
Right. And that's it. You're done.
Yeah.
Now, the shortcut, because that does take a while,
Yeah.
so you don't confuse things,
Uh-huh.
is you distribute the 4 as an exponent,
Yeah.
and then you do 5 times 4, because that's really what we did. If we had 5 4 times, it's the
Uh-huh.
same thing as 5 times 4. So let's just do that. That's quicker.
Yeah.
R12,
Uh-huh.
P16, and boom, there you go.
Yep.
Okay, here. Yeah, kind of the same thing though. Now that you kind of see that shortcut, you can do the same thing here. I mean, you could actually work out A1 to the 1/4 means the 4th root.
Yeah. Uh-huh.
Um, actually, hold on. Let me save my work. Yeah. So you have the 4th root of 81,
Yeah.
which will be 3, because that's what happens when you have a number raised to a fraction exponent. It's the nth root of that.
Yeah.
So anyway, um, so it's 3 to the -2 power. When you have a negative exponent, you do 1 over x raised to that exponent.
Ah.
So you get 1/9. Or you could have done this. Distributed -2 to the 1/4.
Uh-huh.
And it's 1 over and the square root of it.
Yeah.
So because the negative exponent means you make 1 over the base,
Wait, so
and
yeah, but going
and the
back,
fraction makes a root.
yeah, how do you like what do you do if it's like what's the difference between a positive and negative? Like,
Positive, you don't put in the bottom.
oh, so
Negative, you do.
yeah.
If it was just 1/2, then it's just square beta 1.
Okay, yep.
Here, um, so for 1024, kind of tricky.
Wait, what? Yeah.
Uh, so you want to get 1024 as 4 to some power.
Uh-huh.
It's not terribly obvious what you would raise it to, so that's why I'm just going to get a calculator here and just say, well, 4 times 4. Ah,
Okay.
and just keep it times 4. That's 3, 4, 5. So it looks like you gotta do 5 times.
Mm-hmm.
So 2x plus 1 equals 5.
Yeah.
2x equals 4. X equals 2.
Mm-hmm. Wait, so for that problem, for number 4, so you would so like just go back on it, yeah. It's basically how again did you get 4 to the 5th power? Like something.
Yeah, so you have to change
Mhm.
the base
Yeah.
to match the base on the other side.
Yeah.
Sorry, my handwriting's not the greatest, but because the base on the other side is 4.
Mhm.
So you want the same base on the right side, so that way when you have the same bases, then the exponents have to be the same.
Yeah.
And that's what we're doing there.
Mm-hmm.
Right. Okay. Here, you have that.
Yeah.
It's kind of a weird rule, but you have to multiply top and bottom by, they call it its conjugate.
So what happens when it's not conjugate? It's just like, or like, how do you tell if it is?
Whenever you have a radical on the bottom, that's what you have to do
Yeah.
to get rid of it. Because what's going to happen, multiply 6 to 5, 6 to root 11, but then I do 5 times 5 minus 5 root 11 plus 5 root 11 minus 11. And you get 14 on the bottom.
And a radical number is like something divided by or like a square root.
Sorry, repeat that again?
A radical is like symbol like used in a square root or something, right?
Right, right.
Yeah.
Then you need to reduce that 30 over 14.
Uh-huh.
15/7, I think, minus 3 root 11 over 7.
Yeah.
Yeah. So, yeah. Um, I mean, I will say this though. It's a real hodgepodge of stuff. I'm not to rip on your teacher, but I'm just trying to understand the method. I mean, yeah, I understand the last test made sense
Yeah.
because you're doing lines and you're trying to find point, points of intersection, solving algebraic, making that connection. That totally makes sense. I'm just trying to understand that the jump from there to this, and even when you're doing this, I'm also just trying to understand all these different types of problems. Like, it just see, and then also the instructions are not quite clear for 5 because
Yeah.
5 you have to, more specifically you have to say rationalize because it's not really a simplification problem. So it's just a little confusing, but it's okay. Um, anyway, this one here, um, but you're on the right track by multiplying. I like that.
Yeah.
Um, yeah, so you have C. It's actually C6.
Mm-hmm.
You have C3. So basically you have 30. Yeah, you got it. You got it.
Yeah.
Let me just to do a little more of an extended fashion. 4 times 8 is 32. C6, D4. Pull it out. So 4, C3, D2, root 2. There you
Yeah.
go. So yeah, I think you're on the right track. Making a table's good. Um,
Yeah, I know a lot of these problems are incomplete though, because I didn't know how to do that.
yeah, so I think those are 3 good. Let's you did say 2, 5. Okay, that's fine. 2 and -2. So you have the right idea.
Yeah.
Um, yeah, I think your points are fine. Hold on. 1/2, right? Then 1/4. Yeah, and your points are perfect. You got it. You definitely got it.
Yeah.
So you plot the points.
Mm-hmm.
Yeah, it kind of looks like that. And then an asymptote is like a boundary, at least for these types of graphs. It's not true for all types, but for the sake of just keeping it simple for you here,
Yeah.
it's basically a horizontal boundary that it's like a floor. Like it doesn't go below, it doesn't break the floor here.
Uh-huh.
It's y equals 0. As long as you're not shifting graph up or down, which doesn't look like you guys are doing that. Well, I guess you kind of did for 9, but yeah, that's how that looks. And then here, plug in 0, you should get 1/2. Plug in 1, you should get 2. -1 is actually 1/8. 2, you get 8.
What does that say? What's it? Hold on. Oh, wait. So what's like the asymptote? Like what is
Basically, whatever number you're adding to the outside is the asymptote. We call it
okay.
k.
So
Because you're not adding anything, so you say it's y equals 0.
well, what's like the use of it? Like why is it there?
It's to help understand something called M behavior,
Uh-huh.
which is to really understand what the graph is doing, how the ends of the graph behave
Yeah.
as x gets really large.
Uh-huh.
X approaches positive, negative infinity. Definitely, I know you're so far from taking a calculus class, but let's say in 3 years when I'm taking a calculus class, it is kind of a big deal. There are a lot of models that follow exponential growth or decay, where if you kind of want to think about, as time passes, what do we get, work our way towards? Like sometimes, like you might say, as time passes, like if you're looking at like a population and you have an asymptote, ultimately the population goes towards this number. Like it's just kind of like something you consider when you have like when a long time period passes. That's kind of what you use it for. Anyway. That's y equals 0.
Uh-huh.
So you want to go 8 right and 4 up.
Yeah.
So we kind of think of like this: y equals a x minus h plus k, where h is 8 and k is 4, and that's all.
Uh-huh.
Actually, I should do a b, not a. That's the right way of doing it. So speaking of which, we should actually look at this one here. So yeah, that's the general form. That's good. That's good. But you got to plug in 0 for x though.
Yeah.
So 2 equals a times b to the 0 power. B to the 0 power is 1. Anything to the 0 power is always 1. So a is 2. So y equals, plug in 1 and 1.
Yeah.
Like b is 1/2. So that's your equation right there.
Yeah.
Then here, yeah, same thing. I like that. That's good. So a is 1 over b squared.
Uh-huh.
Doesn't really help too much, but it's okay. Actually, we'll leave it as is right now. And then you plug in 4 and 4. So what you could do is, yeah, actually, I think that was right in what I was trying to do here. Isolate a with one of the equations. So yeah, a equals 1 over b squared.
Uh-huh.
So 4 equals 1 over b squared times b4.
Yeah.
4 equals b squared, b is 2.
Uh-huh.
And B is 2, you can solve for A, which is 1/4.
Yeah. So basically, I got a question. So for number 11, am I starting to do it right, or like is it bad?
So well, you're on the right track. Just had to keep going.
Yeah. So it's like incomplete. Complete.
Yeah, it's incomplete. Yeah. Yeah, let me take a screenshot of that too.
Okay. Man, shift 3. Okay.
Okay. Yeah, then we got some word problems here. And we could wrap this up
Yeah.
next 10 minutes. So yeah, using the same formula again, but usually kind of write like this: y equals a parentheses 1 plus r
Yeah.
raised to the x power, where your r is 0.89, it's growth, so you add it on. Um, so 2016. So we should do is let x
Uh-huh.
since 2016. So 322
Yeah.
is your initial value. Yeah, 332, by the way. I said be careful there.
Yeah.
1 plus 0.81, 0.00. Yeah, because you got to divide percent by 100, so it becomes 0.0081 raised to the 14th power.
Yeah.
And you work that, whatever that is, you work that out.
Yeah.
That's just using a calculator at that point. And in here, yeah, there's a form for that also, which, well, I guess you could think of like this. Because if you're doing it yearly, then n is 1,
Yeah.
but monthly n is 2. Sorry, 12. Um, well, I mean, the monthly is going to be a little bit better, but let's say you let a equal $1,000. Let's say x is 2, like 2 years.
Yeah.
You kind of work out each scenario. 0.02 raised to the 2 power versus
Uh-huh.
and you work that out. So, and I think you should get, I'll get my graphic calculator here.
Yeah. I think I need help with these especially these 13 to 12. Like it kind of confused.
Yeah, I can send you some more stuff later today. Yeah, but work it out. Yeah, this is 1040.4. And then it's not much, obviously. It's a very small difference, but I mean, whoop-de-doo, 37 cents. I mean, yes, the monthly's better, but not by much. Very little. Um, and let me actually save that as well. Good bonus. I mean, I'm not sure why that's just pretty easy. You give the formula, right? So 0.2. Whatever that is, you work that out.
Yeah.
And then B, you kind of do the same thing for B.
Mm-hmm.
1095.
Mm-hmm.
Oh, but they have days. Yikes! Hold on.
Yeah, this one I don't understand. It took me like 10 minutes to even like
You have to convert the days to years.
yeah.
Which actually is exactly 3 years. You work that out. So yep. Yeah, and then here is the last one we'll do.
Okay.
Well, let's see if she has enough money. So 151 plus
Bro.
0.0725.
Yeah.
Okay, the formula is this: your initial amount,
Mm-hmm.
1 plus your rate, divided by the number of times you're compounding, raised to the NT power.
Yeah.
And you're doing it quarterly, so that's 4 times a year.
Yeah.
You do it 4 years, you do 4 times 4. And we just work that out. Let's see here.
Uh-huh.
Ah. $199.94.
Yeah. Okay.
So no, not enough. Because that's less than what she needs for the trip. It's actually a cheap trip. Yeah.
Maybe this is like 200 years ago. Who knows?
Or maybe the airfare. I don't know, but who knows? Anyway, from the East Coast. But yeah, that's good.
Yeah, definitely need help with these type problems, just like understanding it for sure. For sure.
Um, yeah, totally. So okay. Um, so yeah, so I think that's good. So let me do this. Let me stop the recording.
Uh-huh.